Okay, problem number 2. How many liters of carbon dioxide gas are produced from burning 24.1 grams of the C7H16 at 512 degrees C, 760 millimeters of mercury? Don't lose that around the edge just because it wraps. So on a problem like this, I guess the other thing we should highlight is liters of carbon dioxide gas again. So our first thing here is a gas. So we want liters. How many liters of CO2, carbon dioxide gas? So let's see, we're looking for that volume. Volume equals how many liters of CO2? And then we also have a mass of 24.1 grams of C7H16. And then we're given a temperature, which is 512 degrees C, and a pressure, which is 760 millimeters of mercury. Now, don't ignore the fact that this is 760 decimal. That's not the end of the sentence. It's not a typo. It's intentional. That's 3 sig figs. All right, so that's kind of all the information aside from the balanced chemical equation that we have. So again, we can tell that this is a stoichiometry problem because it's telling us liters of carbon dioxide gas, and we're producing that gas from burning this other compound. So C7H16, and we want to know CO2, that's 2 different compounds. So we know that we're going to need in the middle a mole ratio that will convert from C7H16 moles to moles of CO2. How do I know which side those go on? Moles of CO2 needs to be on the right side here, right? That's what we're going to because that's what the question's asking for. It's asking about CO2, so we'll have to find that. That means that we can use this, the mass of C7H16, right? If we know the mass, we can use molar mass to convert that back over. So this will be 24.1, or I should just probably write grams of C7H16. Using the molar mass, we can convert that to moles. And then on the other end of this, we have moles, but we want liters. So there's 2 things that you should be thinking that, hey, maybe I could use this. One of those would be PV equals nRT. The other one would be the 22.41 liters per mole. Now, 22.41 liters per mole, can't use that. That has to be STP, or again, the 273.15 Kelvin and 760, or sorry, 1 atmosphere of pressure. So we're not at those conditions. So we're going to have to use PV equals nRT. Maybe we can rearrange this already. V equals nRT over P. And that will calculate the volume in liters of CO2. So some other work we got to do is that 512 degrees C. No good for this equation. That needs to be 273, or added to 273.15 Kelvin, because we need that unit in Kelvin. We need that temperature in Kelvin, so 512 plus 273.15. So that's 785.15 Kelvin. Now, I'm going to take a shortcut a little bit here with my pressure, because pressure also needs to be, so I didn't write an R, we're going to need R. Oops, 821. That's atmospheres, liters per mole Kelvin. So my pressure here, 760 millimeters of mercury. That is, I guess with the correct sig figs, because it's only 3 sig figs, this will be 1 ATM. because if I take 760 and divide by 760 to calculate ATM, I get 1. Since this is not my starting number is where I'm getting my sig figs from, that's 3 sig figs, so it's going to be 1.00 ATMs after. All right, so now I've got everything mapped out. Let's take our 24.1 grams of C7H16, set up our stoichiometry, railroad tracks. So we haven't calculated this yet, but we're going to need the molar mass of C7H16, 12.01. Hydrogen is, there's 16 of them, times 1.01. So pull up my calculator again. 7 times 12.01 plus 16 times 1.01. Look at that, it's 100.23 grams per mole. And now I'm going to plug that in. So I'm trying to calculate moles, which I know from my solution diagram here, and I have grams. So a few different indicators of how to set this up. So my grams goes on the bottom, and 1 mole goes on top. Remember, if this is going too fast, you can slow it down in the YouTube settings, or you can hit pause. You can rewind by either tapping twice on the left side of your screen, or if you're on a computer, hitting the left or right arrow key, that'll skip backwards or skip forwards. Okay, so I've got moles now of C7H16, so I need to use a mole ratio, which comes from my balanced chemical equation that was provided. And we're converting into CO2. And now this is the part where I see a lot of people, they want to just immediately go to molar mass for this next step. But the next step here depends on what we're looking for. So we're looking for liters of CO2, which means, as we just decided before, we need to use PV equals nRT. So since PV equals nRT doesn't fit super nicely into the stoichiometry railroad tracks, I'm just going to go ahead and calculate that moles. So I'm just going to calculate the moles of CO2 now, 24.1 times 14 divided by 100.23 divided by 2. So multiplying by everything on the top, dividing by everything on the bottom, I get 1.68312. I guess I'll take those 8s also. So something to remember is we're not done yet. So we're not writing down this number with the correct sig figs. However, we might want to underline how many sig figs we have. It looks like it's just based on our starting number, so 3 of those are significant. Now I need to take this and plug it into PV equals nRT, which I've rearranged so that it's now V equals nRT over P. Move that calculator out of the way. So this will be 1.6831288. That's moles of CO2. So because I'm plugging in moles of CO2, I'm going to get volume of CO2. You have to make sure you're using the moles of the gas that you want to calculate the volume of. So I can't just plug any moles in and get moles of CO2 or volume of CO2. And this is 0.0821, which is atmospheres liters per mole Kelvin. Temperature here is 785.15 K. That's hot. And I'm dividing by my pressure. So my pressure is 1 atmosphere. Great. So all of that will equal my volume in liters. Pull my calculator out again. Now, I like this calculator app. You can do this on other things too. So with my up arrow there, I can select. You can see that turns pink, reddish pink. And if I hit enter, it just copies that number in for me. So I am actually using the whole number, not even just the numbers that I typed or wrote out. So take this, I multiply by 0.0821 times 785.15. Hit enter. So my volume equals, and now we do want sig figs, so 108, not ATMs, excuse me, liters of CO2. This one doesn't need to be put into scientific notation. If you wanted to, it would not be wrong to write 1.08 times 10 to the 2 liters of CO2. So both of those would be acceptable because they both represent the correct magnitude of the number, so how big the number is, and they both have the correct number of sig figs, which is 3.